Good afternoon, students. Today we're going to discuss about alkenes. So alkenes, this is the second part of an organic compound or hydrocarbon. And this one, alkenes, these are hydrocarbons that contain a double bond between carbon and carbon atom. And the first alkene is ethene. There's no alkenes of methane. It starts from ethene because a double bond need another atom to be attached to. It is unstable. So this is now what we call the simplest alkene. The simplest alkene is ethene. We have the general formula. General formula of finding alkene. This one is CnH2n. Like for example, they can ask you, or this one cannot ask you, but let's just use the formula to find an alkenes with the number of carbon atoms. N is equals to 6. So this is C6, then H12. It takes 6 times 2, that is 12. That is now the general formula. Functional group of alkene is C, double bond C, then we have hydrogen atom attached to. Then the functional group of alkenes. For the alkenes, I forgot to give you the functional group of alkenes. For alkenes, the functional group is C, then hydrogen atom attached to. So the functional group of alkenes is C, double bond C, then hydrogen atoms attached. Then for the alkenes, it is C, then double bond attached, a bond or hydrogen atoms attached to that carbon. So that is now an introduction of alkenes. Take note of the functional group and the general formula. Let's move to nomenclature of alkenes. Nomenclature, and this is where most of the questions will come from. Nomenclature of alkenes. Now, for the nomenclature, the rules that we were using on alkenes are the same as the rules that we would use in alkenes. Like for example, counting the number of carbon atoms so as to identify the longest carbon chain, which would give the parent name. That rule is applied in alkenes, and also that rule is applied in alkenes. The only rule that is different from alkenes is giving the double bond a priority or a number which is lower. Like for example, if this is the compound, we will not start counting from this particular point here. So we'll start counting from this point, because when you count from here, you have 1, 2, 3, 4, 5. But when you start from here, you have 1, 2, 3, 4, 5. You can see we start from the right hand side. Double bonds, the carbon that has a double bond will be type number 3. But when we start from the right hand side, left hand side, the double bond is on carbon number 2, and therefore the rule number 2 states that you count or you give the double bond a number which is lower, or you count from the side that give the double bond the lowest number possible. So you come from and start from the left hand side. This is where the double bond will be as low as possible. So here this compound is called pent-2-ene. Pent-2-ene. Then you also identifying the substituents is another rule there. Like for example, this is another compound. We have substituents attached on it. So for this one now, you identify the longest continuous carbon chain, which will give the parent name. And the parent name here, when you start counting from this side, you will start counting from this side is 1, 2, 3, 4, 5, 6. So that is now hex or hexane. hexane. That is now the parent name. Then you give double bond a priority. So we start from this side, 1, 2. The double bonds attached on carbon number 2. Then we also have a methyl group, which is also a substituent. So the compound here is the name of the compound. Bromine is attached to carbon number 2. So the name of the compound will be 2-bromo. Then hyphen. I said that the name of the compound and the number is separated by a dash. Take note of that one. Hyphen 3. A methyl group is attached to carbon number 4, not 3, carbon number 4. Because this 1, 2, 3, 4, carbon number 4. 4 methyl. Then the double bond is on carbon number 2. Then hyphen 2. Not hyphen, but methyl. Pent. Not pent, but hex. Hexane 2 in. That is now the name of this compound, 2-bromo 4-methyl hexane 2 in. So you can see I have given priority the double bond, then the substituents. So the first thing is to identify where the double bond is located, where the double bond is located. That is now the first thing. Then remember, a dash or a hyphen is separated or separates a number and a letter, or a number in a compound. But a comma will separate a number by a number. A comma will separate a number by a number. If we have very many substituents, we'll find that we are using commas to separate a number by a number. For that case, then this bromine is the suffix for that case. So that is now nomenclature, as simple as that. There's no other thing that to add. That is now the nomenclature of alkenes. Nomenclature of alkenes. The rules are the same. Isomerism. So what is an isomer? In our previous lessons, there was a time where, or there was a point, or there was an incident where we discussed about isomers or alkenes, isomers of alkenes. And alkenes has only one isomer, and that is a positional isomer. But for alkenes, we normally have two types of isomers. We have positional isomer. Now, for alkenes, we normally have branching isomer alone. But for alkenes, we have branching isomer, isomers, and also we have positional isomers. So isomer is a group of compounds that have the same molecular formula but different structural formula. The structure is different, but the molecular formula is same. When you count the number of carbon atoms, you'll find that they are the same. But if you look at the structure is very much different. Now for isomerism, it's now the existence of compounds with the same molecular formula but different structural formula. Isomerism ensures that the term existence exists there. If there is no existence, you will fail. So when you start with branching isomers, here now we are now playing with the substituents, the branches, the methyls, the halogens, hydrogens. That's now what we are playing with. We shift a methyl to another carbon, then we form isomers for that one compound. Example. So branching isomers It occurs when a substituent group is attached to one of the carbon atom in the longest chain containing the double bond. So branching isomer, it occurs when, so let's start with branching isomer. This one, it occurs when a substituent is attached to one of the carbon atom within the longest continuous carbon chain. So when you want to form isomers of that compound, you will now play with that substituent. Like for example, I have a compound here. This is my compound. I have my compound there. So the name of the name of this compound here, it's 1, 2, 3, 4. So it is 4 methyl 1, 2, 3, 4, 5 pentan pent 2 in. That is now the name, or you can talk of pentan 2 in or pent 2 in. All of them is right. That is the name of the compound. Now I want to form another compound that has a different name, but when you count the number of carbon atoms are the same, and also hydrogen atoms are the same with that another compound. Now I will only play with the substituent because we are talking of branching isomer. This is now the branch. We only play with the branch. So I can come here and add another compound. So I may decide and put here and put there a branch, that branch here. So when you put here this branch, when you count the number of carbon atoms, you'll find that the number of carbon atoms 1, 2, 3, 4, 5, 6. It is 6. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9 plus 3. That is 12. Also here it is 1, 2, 3, 4, 5, 6, 7, 8, 9 plus that is 12. You can see this one and this one, the number of hydrogen are the same, carbon also the same for this compound and this compound. But you can see the structure is different. You can see for the first one, the carbons at the branch is on carbon number 4, but this one the carbon is on number 3. The name of this one is 3 methyl pentan or pent 2 in. Then 2 in. You can see the name of the structure is different, but the structural formula is also different. But when you write the molecular formula, we look alike. I can also play with this branch here and come and put here. So it will be 2 methyl pent 2 in. So they can draw for you for they can just say in an exam, they say give the or write all the isomers of 4 methyl pent 2 in. Then they say they put there 3 marks. The first isomer, you write the structural formula of this, the structural formula of itself. 4 methyl pent 2 in. You write the structural formula of that for 4 methyl pent 2 in, a mark. Then you play with the branch. Then after playing the branch, for you ensure that all possible isomers are out. Then you start playing with the positional. Now for the positional isomer, I will not talk much on branching because I taught it on alkenes or when you are doing alkenes. So I will not dwell much on it. Let's move on positional isomer, which is the simplest isomerism. So positional. So for positional, this is occurs when a double bond is attached, or when a double bond is in between a carbon and carbon atom within the longest continuous carbon chain. So for this one, we are now playing with the double bond, only double bond. For example, they can ask you in an exam, give the positional isomer of this compound here. I like using structural formulas, but in an exam they can draw for you the molecular formula. Then it is upon you to write the structural formula or to get the structural formula. So this is the compound 1, 2, 3, 4, 5. This one is pentan, 2, or you can just talk of pentene, because carbon is on double bond is on carbon number 1. I can play with this the double bond and place on carbon number 2, and my structural formula will look like this. This one is C1, 2. Then now this one now will be pent 2 in. I can also play with this double bond and put on carbon number 3. No, not carbon number 3. So when you put here, you will be forced to start counting from this side, and therefore all the positional isomer of this compound pentene are over. There are only 2. The first one is pentene and the second one is pent 2 in. But for this one, you can also write pent 1 in. So that is it. So when you take this double bond and place here, this one will be same as this one, because we'll start counting from this one. We said that when you're giving a name a compound, you need to consider the double bond should be the lower number possible. Another compound like this one, let's say this one C, then this one, then I have a double bond there. Of course, these ones are hydrogen, and ensure that you write this hydrogen. So this one is 1, 2, 3, 4, 5, 6, 7. So the name of this compound is 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4. 1, 2, 3. The name of this compound is heptan 3 in. I can also play with this double bond and either I put here or here. Like for example, when I put the double bond there, it will be when the double bond is shifted from number 3 up to number 4. For example, this one. One, 2, 3, 4. It will be heptan 4 in. You can also shift the double bond. When you shift the double bond to carbon number 3, you can also shift the double bond to carbon number 2, and therefore it will be heptan 2 in, and all those are now the positional isomers for that compound. That is what we call positional isomer. So the question that normally comes to an exam, they will write the name of the compound, like for example 3-methyl 2-heptan 2-bromo or 2-bromo 3-methyl heptan 2 in. Then they want you to write all the positional isomers of that compound. It's upon to write that compound in a structural formula for you to identify whether we have the double bond, whether you can shift the branch or the bond. So that is now, then ensure that you know how to differentiate between branching isomers and also positional isomer. That is also a common question. Branching isomer occurs when a substance is attached to a carbon within the longest continuous carbon chain, but a positional isomer, it occurs when a double bond is in between the carbon and carbon atom within the longest continuous carbon chain. Then ensure that you know how to differentiate between isomers and isomerism. Those two things are very important. That is what we call isomerism of alkenes. I think I'm clear. Pause. Preparation of alkenes. We want to prepare alkenes in the lab. So we normally have two methods of preparing alkenes. Don't confuse preparing alkenes with alkenes. Alkenes is very simple, and also alkenes are the simplest. You normally have simple, simpler. Alkenes is simpler. Then alkynes will now be the simplest. So this one is simpler. So how do we prepare an alkene? The first method for preparing an alkene in the lab is by dehydration of their respective alkanols. Number one, dehydration of their respective alkanols. Dehydration of their respective alkanols. Then the second one is so let us start with the first one, dehydration of their respective alkanols. Dehydration of their respective alkanols. Then we shall look at the second method of preparing these alkenes. For example, when you want to prepare ethene, which alkanol are we going to use? Preparation of ethene. So we are going to use ethanol. So the reagent here, or the alkanol here, is ethanol. When you want to prepare propene, you use dehydration of propanol. When you want to prepare pendene, dehydration of pentanol. This one is simple, and there is a diagram that we need to draw for you. I explain so that you can understand. Pause. So this is now a setup for preparation of alkenes, dehydration of alkenes using concentrated sodium sulfuric 6 acid. So we normally use concentrated sulfuric 6 acid to prepare these alkenes. So ethanol, we have ethanol is used here. Then we have broken porcelain, and I will give out the function of each and every thing that you are seeing here. The function of sodium hydroxide, the function of water, the function of broken porcelain, function of heat, and all other this. So this is now the thermometer you put here, sodium hydrocon, the condensed sulfuric 6 acid. It comes in heat is here, but this is what we call general heating. We use a water bath for general heating. What is the purpose of general heating? Is to prevent breaking or cracking of the round bottomed flask. Now heat the mixture to a temperature of 170. So this mixture is heated to a temperature of 170. Then pass the gas evolved through sodium hydroxide. Collect 4 test tubes of the gas. Carry out the following observations. So sulfuric 6 acid is used to dehydrate ethanol. When ethanol to dehydrate ethanol, to remove water. For this case, that's the function of sulfuric acid, is to remove water from ethanol. Then sodium hydroxide is there and act as it normally absorbs carbon dioxide from this reaction. Remember, when the reaction is taking place, when ethanol is here, comes sulfuric acid, is what you call carbon dioxide there,
and therefore sodium hydroxide is used so as to remove carbon 4 oxide. Then broken porcelain or sanding the flask. This broken porcelain, it normally prevents cracking of the round bottom flask. It can also act as the same way we for general heating. Also, broken porcelain prevents the cracking of the round bottom flask. That's the function of the broken porcelain, prevents cracking of the round bottom flask. Then after that, after dehydration, the gas is passed here, and gas has very many gases, carbon dioxide, and it is now removed carbon dioxide. Carbon dioxide is removed at this particular point. Then the gas is now pure, and now it is collected over water method. Then it is now collected at that particular point as an ethane gas. And also heat is there to increase the faster reaction, or to increase the rate of reaction. So that's all about preparation of alkenes. That is ethanol. When you want to prepare propene, use propanol at this particular point. The functions of each and every compound or component that you have used here is the same, remains the same. Porcelain I have explained, sodium hydroxide the same, and also heating water gently or on a water bath. Thank you for watching. Let's meet another lesson, and that is another way of preparing alkenes.